Okay, here is a review I'm going to go through for the conic sections unit. And let's start off with cross sections. Now, what is a cross section? A cross section is when basically I take a 3D figure and I slice it. So kind of think of like this piece of paper as being like a lightsaber here. And if I were to slice that cone, okay, and I were to open it, what two-dimensional shape would I see here? Now, I do have a little interactive thing I found here on GeoGebra, right? And so as I look at this, I notice here's my piece of paper, and if I were to view it from the cross section here, if I click on this, I turn it here, and let's make the 3D shape go away, okay, then all I have is this circle. So if I were to, let me refresh this, slice this cone horizontally, okay, I would have a circle. Now, what if I sliced it vertically? So I'm going to go ahead and flip this, and you'll notice it's taking that piece of paper. So I'm slicing it right down the middle. And again, if I view it from the cross section, if I were to open up this cone, what 2D shape do I see? And my answer is a triangle. So, okay, so question number 1, triangle. Now, your review might not be the exact same as mine. Okay, it's a number generator and a shape generator, so every single time somebody in the class takes a review, it could rearrange the shape or numbers. Okay. Okay, this one right here. If I were to take this piece of pie here and slice it, what 2D shape would I see? So I'm going to look at this right here, and I notice now it does kind of look like a parallelogram the way I drew it, but if I were to pull it off because it has depth, it would be a rectangle. Okay, question number 3, same thing. What if I were to slice this thing horizontally, like I see right here? Okay, now you'll notice, obviously, this is a cone, so the only one that's circular up here. And I do have, I would see like, I'd have a hole here, so I'd have kind of like a donut. So I'd have this circle here if I were to sketch it like this. And then I'd have this little mini circle here in the middle. So the correct answer is C. Okay, if I were to slice it vertically, so I've kind of got like this sheet of paper here. I don't know if I could sketch it. So like this. And it slices right down here, and I see it right here, right? Okay, you'll notice as this paper goes through for vertically, the correct answer here would be D. Okay? And again, what I don't see is I'm looking at the 2D shape, but again, if I were to tip it upside down, you'd have something that looked like this, right? And that's what I would slice right down. Okay, let's go to the next problems. Those are pretty quick. Okay, which one of these would produce an equilateral triangle? Now, you do have to remember an equilateral triangle is a triangle where all 3 sides are the same. Boom, 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 that's equilateral. And just looking at these, since this point is kind of the midway, I would say yes, these 2 are the same, but this one would probably be longer. This one here, this definitely looks like a short little side here, and I can't really guarantee that any of these are the same length, really. But last but not least, since these go corner to corner, okay, I notice, boom, that's going to cut across this part of the cube perfectly right down the diagonal. And I've got the same thing here. So my front cube, that is a diagonal. So as long as this is a cube, and again, that's a diagonal. So my correct answer here is C. This is the only one where all 3 of those lengths would have to be the same. Okay, equations of circles. Here's what an equation of a circle looks like. It's always x minus something, quantity squared. We say y minus something, quantity squared, equals r squared. Now, in the formula, they'll have an h here, and they'll have a k here. I don't really care about the h and k. All I care about is x goes with x, y goes with y. So if I look over here, I notice with the x is 3. And you'll notice subtraction is part of the formula. So subtraction, subtraction. So the only number I could plug in there that would give me x minus 3 in parentheses, okay, would be a positive 3. You'll also notice over here, y is by itself. There's nothing here. Okay, there is something I could put here that would put y by itself, and the answer is 0. If I had y minus 0, I wouldn't even need y minus 0. I'd just put y squared. 0. So this is my center point. Make sure you answer in parentheses with a comma. And my radius. I notice the radius is going to go in this spot. But in my formula, I have r squared, but I have 49. Well, what number do I multiply by itself to get 49? And the answer is 7. Okay, same thing. I'm going to go ahead and clone this and move it down. Same process. Might shrink this a little bit. Shrink it up so I can write. Okay, but I'm going to leave it blank where this r goes. So they give me a point here. X goes with X, Y goes with Y, and R goes on the outside. Now, be careful here. Don't forget you have to square this number. So I already know that D and A are out. They probably put these in here just to trick you. And so I know it's got to be either C or B, and the one that has subtraction in it is C. So correct answer is C. Okay, same thing. I'm going to clone this. I'm going to bring it down. We're going to fill in the blanks. Okay, there's an X. That's going to go in the X spot. There's a Y. That's going to go in the Y spot. There's a radius. That's going to go in the radius spot. So let's plug our numbers in. I get negative 10. Now, when I subtract a negative, that turns into plus 10. I'm plugging in a 5. Subtraction is part of the formula, so I leave it alone. And then I'm going to plug in the square root of 5 here. Now, what happens when we square a square root? Okay, these are opposite operations. Just like add is to subtract, multiply is to divide. And when I square a square root, they basically cancel each other out. Okay, so I know B and C are out. And if I look closely, looks like D down here, my signs are wrong. So my correct answer here is A. Okay, same thing, except this time they give me a picture. So I'm going to start off by finding this center point. Center. And I notice from the origin I go to the left 2 and I go down 5. So negative 2, negative 5. And then I'm going to find a radius. Radius equals. Now I'm not going to count radius at a slant because we don't like counting slant lengths. I'm going to count to the right or up or left or down. I notice every direction it's going to be 4. Okay, so radius equals 4, that goes here, and now I'm just going to make the equation like I did up above. So let me clone this, I'll bring it down. Okay, X goes with X, Y goes with Y, so negative 2 is going to go in this spot, negative 5 is going to go in this spot, and my radius here is going to go in this spot. So let's fill in some numbers. Remember, when I subtract negatives, it's going to change to plus 2. When I subtract negatives, it's going to change to plus 5. And then we'll go ahead and plug in our radius squared. Now, the program, if you type it in this way, probably won't make it accurate. So you actually have to change this to 16. So actually square that number. Okay, now we're going to graph. I haven't played around with the graphing tool, but I'm sure you have done it in previous assignments. So all I need is a center and a radius, and I can graph this pretty quickly. So let's find our center, and it will be some coordinate point, and then we'll find our radius, and then we'll graph it. Okay, so just looking at my equations. Plus 5, and hopefully from the last problem you'll notice subtraction was in the circle equation. The only thing would change it to a plus 5 is a minus 5. And then I've got minus 3. right here. Subtraction is part of it, so it's a positive 3 would go in there. And then r squared. Now this is not my radius. That's my radius squared. And the only number you can think square root of that, or what number do I multiply by itself to get 9? And the answer is 3. Okay, here's how you plot it. You'll start with a point. So I'm going to go left 5 and up 3. There's my center point. And from that point, I'm going to go up 1, 2, 3, to the right 1, 2, 3, down 1, 2, 3, left 1, 2, 3, and then we will connect it and make our circle that looks like this. Boom. Okay, let's do it again. So I need a center, and I need a radius. Okay, I notice +1. The only thing that would change that negative to a positive is I plugged in a -1. Okay, right here, +5. Again, -5 would change it to a +5. And then last but not least, 25. So the only number I multiply by itself to get 25 is 5. Okay, so let's plot it. Left 1, down 5. There's my center point. From my center, go up 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5. Down 5. And left 1, 2, 3, 4, 5. And again, you'll have to play around with the graphing tool in Math Excel. Okay, this is a good problem. What I would do in this problem is it says I want to know the length of this chord. So I need to know the distance from here to here, right there. Now, you'll notice if you look really close, these dots are not on nice clean grid lines. So it's not as easy as counting. What I would do, though, is I would turn this into a little right triangle. I know this length is 1. I don't know this length, but if I had that vertical length, I could double it. And I'm going to make this into a little right triangle. Now, I also know the slant length, because that slanted length is my radius, right? And as I roll around my circle, my radius, I can count this radius. I see it's between 2 and 4. It's on a nice clean grid line. It's 3. This radius is 3. This radius is 3. 3, which means this is also 3. Okay? So I'm going to go ahead and pull this triangle off. I'll make a little sketch of it over here. Larger version, so I know this is 1, this is 3, and I'm looking for this. So let's use the Pythagorean theorem. It is a right triangle here. So I'm going to say a squared plus b squared equals c squared. Okay, my c has to be my hypotenuse or the side opposite the 90-degree angle. I would probably just change these into numbers. A squared plus 1 equals 9. I'm going to do a little basic algebra. I need to make this go away. So the opposite of adding 1 is subtracting 1. And these are gone. Now I get a squared equals 8. And the way I make this go away, the opposite of squaring something is square rooting. So a equals the square root of 8. Now that's probably going to give me a decimal answer, and you have to remember that that's only half of the problem. Okay? You have another segment that should make the same right triangle down here. So I'm going to go ahead and double it. So let's figure out in a calculator on what is the square root of 8. So square root of 8 is roughly this decimal. Okay, the more decimal places of accuracy, the better. So from here to here is roughly, I'm going to like 2.83. 2.83. And then I'm going to double it times 2. And the whole length here, from here to here, is going to be roughly 5.7. And that is my final answer. I think it says to the 10th, yes. 5.7. Okay, question 12. This one, I already know the correct graph. I know this is going to make a circle, and it's going to be centered at the origin. So like D is out, C is out. It's between A and B, because I can just see the center of this is not at the origin, the center of this is not at the origin. So these are no good. And I already know that this is going to make a horizontal line at +2. Well, this is a horizontal line at -2, so that's no good. And this looks like the correct one. So this is my graph. Now, where are the intersection points? Now, this is not very clean. Even if I blew this up, it'd be hard to see. So I would use the graphing calculator we have. And I already typed them in for us here. So this is, you type in the equation of the circle just like you see here. If I want to, I hit this plus button over here to make a new expression. So in red is the circle, in blue is the horizontal line. And the nice thing is I just hover my cursor over, and it will give me intersection points. So when I go here, boom, there's my intersection, and there's my intersection. And those are my points of intersection, and that's the easiest way to do this. So let me go back. Okay, now the way we type that in, okay, let me look one more time. It was -3 and 2 and 3 and 2. So it is picky. I got to write it in as a point, -3, 2, close it. It says use a comma to separate answers as needed. Then I'm going to put another comma, and oops, this one would be +3 and 2. Okay, last problem. Okay, we are looking for what quadrant will both of these answers be negative, less than 1. So I'm going to make a little XY axis, and let's start with sine. Okay, in the trig world, sine is opposite over hypotenuse. So if I were to make a triangle out here in quadrant 1, you'll notice my opposite here would be a positive number because it's going up. And this is my radius or my hypotenuse. And my radius is always going to be positive. And so whatever numbers I had here, like if this were 4 and 5, okay, I would have a fraction that is greater than 1. Okay, so quadrant 1 does not work for sine. Okay, let's look at quadrant 2. Maybe if I'm over here. Again, this is positive going up and positive. That would give me a positive number. Let's look at quadrant 3 here. So if I had a angle down here and I made it into a right triangle, okay? Now, this would give me a negative number because it's going down. A negative, and my hypotenuse here technically is going to be positive. It's like the radius of a circle. The radii should always be positive. So whatever I got here, if this were like 8 and this were -5, if I were to plug opposite of hypotenuse, I would get a negative number. So this quadrant here is where sine is less than 0. Okay, let's look to the right. Let's say I do the same thing over here. Again, opposite would be negative over hypotenuse, which is positive. So this would be another quadrant where sine is less than 0. Okay, what about my tangents? Okay, tangents are opposite over adjacent. So if I made a little right triangle here, okay, quadrant 1, opposite would be positive, adjacent would be positive. Because I go to the right, it's positive, I go up, it's positive. So that's not negative. Maybe I make a little triangle over here. Let's do a better job. Okay, opposite is positive, but adjacent is negative. So this would be a section where tangent is less than 1. And again, if I plugged in some numbers, like what if this is 5 and this is -2? I would get -5/2. So tangent here is less than 0. If I went over here to quadrant 3, I know this is negative and I know this is negative. But if I plug in some numbers here, like if this was -2 and this was -5, if I did make that into a fraction, negative opposite over adjacent, these negatives are going to cancel each other out. So that would make a positive number. Let me get rid of some of this. Don't need those numbers there. No, why did I get rid of that? Save that. And last but not least, let's look over in this quadrant here. This is a positive number for my adjacent. This is a negative number. So think about it. If I plugged in like a 3 here and a negative 4 here, that would make a negative fraction. So this would also be tangent is less than 0. So it says name the quadrant which both of these occur. And the way we name our quadrants, this is quadrant 1. In Roman numerals, this is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay? The V represents 5, and the one before it subtracts. So the correct answer here is quadrant 4. And that's it for the review. Good luck on the test. Don't need this. Let's go ahead and stop.